Welcome everyone. This is 14.2 on parallel lines. But before we talk about parallel lines and what they create, okay, we have to define them first. So parallel lines are two or more lines that will never intersect. Okay. The symbol for parallel lines is right here. Okay, it looks like two vertical lines. So if line A is parallel to line B, how we signify that is through this statement here. Okay. Sometimes it'll just be written as A is parallel to B without the words line in there. Sometimes there will be lines, but they both mean the same thing. Also, how to signify that they're parallel on the figure itself are these symbols. Now, I want to make it clear. Without these symbols, you cannot, without these symbols or an indication like these guys here, right? We cannot just assume that they're going to be parallel. Okay. So, meaning if I see these lines here, oh, eyeball it, these lines look parallel. We cannot say that. Okay. We need these arrows, right, to tell us that they're parallel. Got it? Okay. So, the next word that we have is a transversal, and a transversal is a line that intersects two or more lines. In this section, those lines will be parallel, okay? But you see the blue line right there, that's called the transversal, and I'm going to label it angle or line T, okay? So line T is my transversal, where line A and B are parallel because we have these symbols here again, right? And the transversal line T intersects A and B at two different spots, right? Right there and right there. Okay, so that's what a transversal is. It's just a line that cuts two or more lines. All right. And then when a transversal intersects two or more parallel lines, these special angle relationships occur. Okay, and this is what we're going to talk about today. Okay, so when we have this picture, when we have two parallel lines and a transversal intersecting those lines, then these special angle relationships occur. Okay, so the first special angle relationship is called corresponding angles. Okay, and the general definition of corresponding angles is just angles in the same spot. All right. So if we look at, or if we group angles 1 through 4 together, and we treat the transversal, the blue line, as like an escalator, these angles 1 through 4 are going down the escalator, right? Yeah. And you can imagine that they are going down the escalator to these four, 5 through 8 angles. Okay. So my question to you is what corresponds or what angles are in the same spot? Angle 1 is in the same spot as angle 5. So angle 1 and angle 5 are corresponding. Angle 2, angle 6 are corresponding. Angle 3, angle 7 are corresponding. And angle 4, angle 8, right, are also corresponding. So now what type of relationship do they have? I'm going to take one of these four corresponding angles and just dive in. I'll take 3 and 7. Okay. Notice that angle 3 is made up of the parallel line A, right? Parallel line A and the transversal T, correct? Yeah. And 7 is also made up of the parallel line B and the transversal T. Yeah. Since they are made up of the parallel lines, they have the same slope, and they are made up of the same line, line T. So that means that they are going to be equal to each other, right? So I can say corresponding angles are congruent. Okay, so they're all congruent to each other. Okay. All right. So they're all going to be congruent to each other. And this brings up a definition. Okay. So I can say if two parallel lines are, I'm just going to use the letter R, cut by a transversal. And cut by transversal is going to be labeled as CBT. Okay. So whenever I say CBT, it just means cut by transversal. Okay. So if two parallel lines are cut by a transversal, or if I have this picture, right? If I have two parallel lines are cut by a transversal, or this whole picture kind of is represented by that if statement, right? So if two lines are cut by transversal, then corresponding angles are congruent. Okay? That makes sense? Yeah. So let's dive into an if-then statement. I want to make one up right now. If I go to McDonald's, then I will get a Big Mac. What has to happen first? If I go to McDonald's, then I will get a Big Mac. Yes. I gotta order it before I order it. Well, I gotta go to McDonald's first, right? That has to happen first, correct? If I go to McDonald's, then I'll get a Big Mac, right? I have to physically go to McDonald's first. Same thing with this if-then statement. If two parallel lines are cut by transversal, then corresponding angles are congruent. I must have two parallel lines being cut by transversal first. And then the corresponding angles are congruent, right? So I must have this picture first. Okay? That makes sense? All right. So that is what I wanted to emphasize. And the next four special angle relationships are based upon these words. Alternate, it means alternating sides of the transversal. So left and right, left side, right side of the transversal. And then same side is the same side of the transversal. Interior and exterior, inside of the parallel lines and outside of the parallel lines. If you guys cannot see that, all right, here is something that will help. If I make a box inside the parallel lines, right? There's my rectangle, right? On the inside of the box is the interior angles. So 3, 4, 5, and 6. On the outside of this box, angles 1, 2, 7, and 8 are the exterior angles. Okay? So mix matching these words, alternating in the same side, and then choosing interior, exterior, we have 4. Okay, we're going to go through 4 of the special angle relationships. Okay, so the first one, we have special angles, alternate interior angles. Okay, so alternating sides of the transversal and interior meaning inside of the parallel lines, right? Give me an example. Yes. 3 and 6 and 4 and 5, right? 3 and 6 are on alternating sides, and 3 and 6 are also on the inside, right? Along with 4 and 5, same thing. So angle 3, and angle 5. Was it angle 5? No, angle 6. Angle 6 and angle 4 and angle 5. Okay? They're alternate interior angles. Now we're going to talk about what type of relationships they have. I'm going to take 1, 4, and 5, and let's dive in. Okay? So can I say angle 4 right here and angle 1 are congruent? Why? They're vertical angles, right? Yeah, they're vertical angles, so they have equal measure, right? And I can say now angle 1 is congruent to angle 5 because they're corresponding angles, right? So if angle 4 is equal to angle 1 and angle 1 is equal to angle 5, can I say angle 4 and angle 5 are also equal to each other? Right? If you need more of an example, I'll put an angle measure there, 120. If angle 4 is 120 degrees, angle 1 is also 120 degrees. If angle 1 is 120 degrees, then angle 5 is also 120 degrees, correct? So you can see that angle 4 and angle 5 are both 120 degrees. Yeah? So alternate interior angles are also congruent. Okay? So I can say angle 3 is congruent to angle 6, and angle 4 is also congruent to angle 5. Okay? The next special angle relationship we have is alternate exterior angles. So what are alternate exterior angles? Alternating sides of the transversal and on the outside of the parallel lines. Angle 1 and angle 8, right? Angle 1 and angle 8 and angle 2 and angle 7, right? They are alternate exterior angles. So angle 1 and angle 8 and angle 2 and angle 7. Okay, and how I'm gonna show that these guys have a certain relationship. I'm gonna get angle 1 and angle 8. Okay, let's talk about angle 1 and angle 8. Again, can I say angle 1 is congruent to angle 4? 120 and 120? Yeah, because they're vertical angles. Angle 4 corresponds to angle 8, so that's also 120, right? So I can say that they're congruent to each other, correct? So alternate interior and alternate exterior angles are both congruent to each other. Okay? Next one, next special angle relationship, same side interior. Same side interior angles, okay? What are same side interior angles? 3 and same side. Same side of the transversal and on the inside of the parallel lines. 3 and 5 and 4 and 6, right? So measure or angle 3 and 5, and angles 4 and angle 6. Okay? And again, to showcase what type of relationship they have, I'm going to look at 4 and 6. Okay. Can I say, class, that angle 4 plus angle 2 equals 180? Right? Because they make up this line here, right? Since any line is equal to 180, angle 2 and angle 4 are linear pairs. Yeah? Yeah? Everybody got that? So I'm gonna make this, again, 120. If angle 4 is 120, what is angle 2? 60? Everybody understands that that's 60 because the whole thing equals 180, right? If angle 2 is 60, can I say that equals angle 6? Why? And notice that I'm always asking why. This is the skill that I'm trying to build, okay, in you, because the next step to this is proving. And when we're proving, we have to always answer why, because that'll be our reason why I can say that. So how can I say, or why can I say angle 2 and angle 6 are congruent? Why is angle 4 and angle 8 equal? No, they're congruent. They're corresponding angles. Who said that? Yeah, they're corresponding angles, right? And we already built that corresponding angles are congruent, right? So that's why angle 2 and angle 6 are also corresponding angles. And that's the reason why that they are congruent. Okay? So if you can see 120 plus 60, that also equals 180, right? So I can say that they're supplementary because supplementary angles equal 180. Okay? So I can say measure of angle 3 plus the measure of angle 5 equals 180. And the measure of angle 4 plus the measure of angle 6 also equals 180. Okay? Same side exterior angles are also going to be supplementary. So I'll just show you guys this. I can do the reasoning again, same exact way, just with different numbers. But what are same side exterior angles? Let me erase all of this. What are same side interior angles? Or same side exterior? 1 and 7 and 2 and 8. Okay? So I can say measure of angle 1 plus measure of angle 7 equals 180, and measure of angle 2 plus measure of angle 8 equals 180. Okay? And then we know corresponding angles are congruent, and these guys are the corresponding angles. Okay? I just copied and pasted from the first one. All right? So last thing about our notes, and then we'll dive into some examples. Okay? Remember our definition. If two lines or if two parallel lines are CBT, remember cut by transversal, then dot, 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 then I know alternate interior angles are congruent. Then I know alternate exterior angles are congruent, then I know same side interior angles are supplementary. Then I know same side exterior angles are supplementary and corresponding angles are congruent. Okay, we must have that picture first, right? We must have two lines that are two parallel lines are being cut by a transversal first. Okay, then all of these 5 different special angle relationships occur. Cool? Yeah. So for our examples for this one, it's just figuring out what we have and then using that special angle relationship to solve for x. Okay, so we're given the fact that m is parallel to n, right? So I'm going to draw these arrows because I know that because it's given to me. Find the value of x. What angle relationship does x and the angle that I know 34 have? Yeah. They're alternate exterior angles, right? If they're alternate exterior angles, they must be congruent. So x needs to equal 34 degrees. Okay? Simple? Okay. Let's try this one. I'm again given that m is parallel to n. What angle relationships? How am I going to solve for x? They are on the same side of the transversal and they're on the outside of the parallel line. So they're same side, exterior angles, right? And they add up to 180, correct? So I know x plus 167 equals 180. So subtract 167 on both sides. Or you could just jump down to 180 minus 167 equals 13. Okay. Cool deal. I'm going to skip a couple of these. Let's try this one. Given that L is parallel to M, which is parallel to N, I honestly don't even need line N. It's there to kind of confuse you. So I want to cover it up with my screen. What type of relationship does x degrees and 125 have? They're corresponding angles, right? They're in the same spot, right? So if they're in the same spot, they're corresponding angles and corresponding angles are congruent. So that's just 125. Cool? So we're going to just be doing these type of examples. Okay? The last thing I want to talk to you guys about is a preview of what's coming up. And it's on proving two lines are parallel. Okay? I'm going to show you guys this picture without the given statement. Okay? I'm going to have to prove that line M is congruent or is parallel to line N. Okay? That the vertical lines are going to be parallel. How do we do that? Now, we just learned 5 different types of examples, right? 5 different special angle relationships, right? And we said if two lines are cut by transversal, then I have all of these 5 relationships, correct? That's the beginning part of parallel lines, okay? But in order to prove that these parallel lines or these two lines are parallel, we have to prove that one of these 5 exists. And then we can say that the lines are parallel. Okay? So there's going to be 5 different reasons we can use when dealing with proving parallel lines. And those 5 different reasons are, hey, alternate interior angles are congruent, alternate exterior angles are congruent, and so on and so forth. Yeah, those 5 right there. Okay? Does that make sense? Yeah? And that is the lesson for today. Okay? So the big idea is right here on the screen. Thank you very much.